Okay, class, it's audible now or no? Okay, let's see how long it continues. I am not changing anything. Okay, so we have an array here, balance 5, having 5 elements. And if you see, when I'm calling and when I'm passing the entire array to the function, right, I just need to write the name of the array. I will show you 2 3 methods by which you can do, and all are correct actually. The first and the simplest method is you just write the variable name like it's a simple integer, right? See, even though balance is an array, right, it's a subscripted thing, it's an array, but still C allows us that flexibility that even if you are passing an array, you can just use the variable name. But the thing that you need to remember is when you actually define the function, you need to specify that this balance, which will be copied to array variable arr, is an array. So you need to specify the empty parenthesis. So what would I suggest is that you always keep this bracket as it is, right? It actually helps you remember few things that, okay, whenever we are passing an array, pass with empty square parenthesis. Just one rule to remember, whether it's a function declaration, whether it's a function call, or whether it's a function definition, you always use square empty parenthesis. So less remembering, simpler rules, right? Okay, so it is giving me error. Okay, let me just check. Strangely, some compilers give strange errors. Should not have given that error, but okay, let me just pass on. If I pass on the exact this, still probably won't take. It will give an error. Okay, so while passing, we need to pass the simple, we need to pass it using a simple variable name. So just remember this. Strange, it was giving an error. But anyways, so when you are passing an array, you just use the variable name. That's it. And when you are taking this variable, you need to actually specify this parenthesis, saying that it's an array variable, right? Let us see what happens if you remove this also. Let us see what happens. It probably will give error actually. Yeah, it's giving an error. Fine. So two things to note: when you are passing an array to a function, just use the name of the array without the square parenthesis, right? But when you are calling, when you are declaring or defining, see, this is function definition, right? This is function definition. That means we are declaring the entire function here. So what this function is doing, taking the average. So array has my balance array, which is having 5 elements. And see, you need to also specify the size of the array. C has by no means to determine what is the end of the array, right? Technically, I could have a balance array having 35 elements, but only defining 5 useful values. Others would be basically some random values or 0, depending on the compiler to compiler, right? So for that reason, you are specifying the size of the array. That, okay, my array contains 5 elements. You need to compute on those 5 elements only. So what I'm doing here, I'm just going from 0 up till size, and then I'm adding all the values and then dividing by size, returning the average value. We have a return statement here, and what is the data type of the return here, which is double, right? It can be float, integer. Float is better because the average may usually return a floating point value. So just keep in mind that since you are returning a double value here, right? See, you are returning the variable name average, and the function says that this average should be of type double, right? So you can see average is defined as a double, and then you are returning double again. So when you are returning the average, it will be stored in the variable called average. This can be a different variable also, right? The name can be different, but I will explain you again in the scope part. So remember that since you are returning average, which is of type double, in the main also the type of average should be a double variable, right? So let me just, for clarity purposes, let me keep this variable as avg underscore 3, so that you realize that even if you change the variable name, it won't have any effect. Right, the average still is 214.4. So this avg, which was of type double, right, and the function was also returning double, is basically stored in this particular variable, which is avg underscore 3, right? So don't make a mistake, like let's say you define float as avg3, but your function is returning the average in double. You may get a right answer or you may not get a right answer, right? It actually depends. So let's say you are having this as integer, right? And eventually you are returning the type of double, so you will surely get a wrong answer. See, the average is 0. So even though your logic is correct, but what was happening here, you are returning average, average is defined as double, the function is returning the double, and where will the return statement go? From the point where the function was called. The function was called on line number 16. In the line number 16, we are storing this avg value in the variable called avg3, which we defined integer. The function was returning double and we defined the average as integer, which is a mismatch, right? So keep it double. You can go to a higher thing. So for example, if you are returning integer here, let's say avg was an integer, and in the main you are defining avg as a float value, that is acceptable, that is not an issue at all, right? And that happens because, see, for example, you cannot define a factorial for floating point numbers, right? There is no factorial for 5.3. Fine. So when you are taking an input to a factorial, right, you can take an integer input, but while returning, because a factorial gets huge, then you can keep it the return type as double. So I hope you just keep these basic things in mind, that whenever you are returning something, ensure that the return type and the catching type have the same data types, right? So this is done. And you can also pass a multi-dimensional array, right, to a function. So again, a very simple example here. I'm taking a two-dimensional array having 2 rows and 2 columns. So I can store 4 numbers here. Just the standard, because I have a two-dimensional array, I will use 2 for loop. If I have a three-dimensional array, I will use 3 for loops. For n-dimensional array, I will use n for loops for inputting. Just a simple rule. Now again, what I am using, I am passing the function, passing the multi-dimensional array to a function, right? See, as you can see, I am just passing the name of the array. But again, while catching the variable, you need to define the, see, basically I can use this approach also, but since it's a two-dimensional array, we need to specify both the indexes, because see, a 2 cross 2 array, it has 4 elements, but so is a 1 cross 4 array will also have 4 elements. A 4 cross 1 array will also have 4 elements, right? So in case of multi-dimensional array, unlike single dimension, where in single dimension you just specified an empty parenthesis because it was single dimension, right? And we were passing the size separately. We cannot do the same here, right? We have to specify the exact index of rows and columns, and then I'm just displaying the value using the standard 2 loops, right? So this was the method by which you can pass an array or a simple variable to a function. So any doubts or issues till now? Yeah, average one. Okay. Okay. No, it won't show an error. Actually, C compiler, the property is it does not do a array of bounds checking, right? So let us do one thing. So 35 will not do. Let us do for 8, right? And just for simplicity, let me keep it simple. 1, 2, 3, 4, 5, 6, 7, and 8. Fine. So if we take 5 values, the average of first 5 values will be, I think, 3, right? 9, 12, 14, 15. Yeah, 5 values will be 3. So let us try with this example. So with programming, it is always good to do hands-on, right? So I have a array having 8 elements, but I am passing only the size as 5. So let us see what average does it provide. Right click, run the code. So see, the average is correctly set as 3. Fine. So let us take the average of first 2 values, right? 1 and 2. So it should be 1.5. So it is coming. So I think your doubt now clears, right? So you can also, yes, So what will you do with the link function? That part I didn't understand. Okay. Okay. C, I'm not sure whether it supports the length function. Python does support the length function of an array, but C, I do not know if the latest compiler supports the length function, but there is no length function as in C. C has a length function for string, right? So for example, let's say if I define something, suppose character country, I define a length and I say this as India, right? So C has a function known as strlen for country, right? I mean, I have to include the library, but something of this function is there in C, right? So this will basically say me that India is of length 5, but C does not have any ways by which I can give a length function for balance and say that it has only 5 elements. What does C compiler actually do is that, see, once you are saying balance of 35 values, even if you write just a single value here, right? Let me just copy this, copy, paste, I'm doing this. So let's say even if I'm writing 350 values and let's say my array contains only one element. So what will the compiler do? It will assume that the length of the array is actually 350, even though there is only one element. Right. So to answer your question, what you can do, let's say if you want to write a dynamic program wherein the user can enter as many value as they want and then get the average. So what you can say to the user is like, so you can keep a value. Okay, let's say you can ask the user to keep on entering values, keep a very big array and say that when you are finished entering, enter -1 or something of such value, -99, -10,000, something like that. So the moment user enters -9, you assume that that is the end of the array. Then you will write a for loop and go up till -1 and keep a count. So you will get the count of the actual values. I hope that makes sense, right? So this is the thing. Okay. So now, class, we can take a break for 2-3 minutes and then we can be back to the last part of the lecture. हाँ 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 बोलो बोलो यस हार्दिक यस I think somebody was asking a question. Yeah, they can continue. I cannot hear you right now somehow. Acha, class, am I audible? But somehow I cannot. Yeah. So, someone was asking a doubt. Yes, yes. Someone was asking a doubt, and I think he stopped in between. They can continue with their doubt. Okay, class. So the last part of the lecture, we are having something called as swap y value, that is function underscore 4, right? So this is something very interesting, and we will begin into pointers. Let us see whether today or tomorrow. Probably tomorrow. Yes. Okay. Let me just. Yeah, but the compiler was giving errors, so we didn't put it, right? So you need not put, right? So in only the function declaration and definition, you put the array subscript, and while passing the value, you just pass the name of the variable without the subscript. Fine. So that should be it. Yes. Hmm. Correct. Okay, so should we try it? Yeah, it won't. No, actually, see, it's not about the format. Actually, this is something. Okay, let me just tell you. So what happens actually depends on the architecture. Nowadays we have 64-bit architecture, right? So you assume that we have a 4-byte storage for integers. So what do I mean by 4-byte storage? So 1 byte basically, I do not know whether you know this. 1 byte is basically 8 bits basically, right? So 1 byte is 8 bits in a computer. So let's say an integer will take 4 bytes in memory, right? So whether you define a number as small as 1 or as large as 2 raised to 32. So okay, let me try to show this in Excel if I can explain you how the storage is done in computer, right? So the Excel is visible. Let me just try to. So let's say when I say, okay, so let's say when I say I'm storing a 4-bit number, sorry, okay, let us take a 4-bit number, right? Not byte. Bit is the smallest unit in computer, right? 1 bit is a single digit, a 4-bit number. Because computer only sees zeros and ones, a 4-bit number will be 0, 0, 0, and 0, and the max will be 1, 1, 1, and 1, right? Simply stating this, basically, if I am giving, see, because in computers, everything is a binary number format. So what does binary mean? Binary means by means 2. So what are the two possible numbers? Which is 0 and 1. So any combination of zeros and ones. So for example, if I have a 4-bit number, what is the maximum number that I can do is from starting from 0 till 2 raised to, because it's a 4-bit number, 4-bit minus 1, because I'm including 0. Let us even take a simple example. Let us take only a 2-bit number, right? So what will be the combination? 0, 0, because I'm having 2-bit, 0, 1. I can have 1, 0, and I can have 1 and 1. So this gives me 4 possibilities, which is nothing but 2 raised to 2, right? If I have a 3-bit number, so what will have a 3-bit number will have something like 0, 0, 0, 0, 0, 1, and so on. So let me just write a shorthand for it. You write 4 zeros, 4 ones, double 0, double 1, double 0, double 1. So this is like a hack actually. So it automatically converts. So in, if I convert, see, this is a binary number 0, 0, 0. So I am writing the decimal equivalent. This is 0, 1, 2, 3, 4, 5, 6, and 7. Right? So you can see I have 8 values here, right? So if I do a serial number wise, 1, 2, 3. Okay, let me just show you. So you can see serially I have 8 values. Because it was a 3-bit number, I am having 2 raised to 3. Why I am using 2 raised to 3? Because it's a binary number, right? Binary has only 2 possible values. Let's say if I say you have 3 decimal numbers, right? And what is the maximum number that you can get? So you will say it will be 10 raised to 3 minus 1, because I assume from 000 to 999. Now why did I do 10 raised to 3? Because a decimal has total of 10 digits, 0 to 9. Similarly, a binary has 2 digits. So given 3 bits, I can have a maximum of 2 raised to 3 values. So I have 8 values, but those values are 0 up till 7, right? So now what happens when you use a 4-bit number? Let's say you are storing an integer which is of 4-bit. So 4-bit means, sorry, let me just write here, integer is 4 bytes, which is nothing but 32-bit, because 1 byte is 8 bits. So let me just write a serial number here. Although floating point arithmetic is a bit complex, 29, 30, okay, 29, 30, 31, 32, right? So you can assume this is to be the most, okay, let us forget the term. So if you want to store 1, right, how will the computer store the 1? It will store something like this: 0, 0, 0, 0, 0, 0, 0, and finally it will store 1, right? So what will be the maximum value in 32-bit? All ones. If you make these all values 1, it will be the maximum value. So this is how the computer actually stores an integer value. Whether you are storing 4 or 5, internally the computer will store it like this, right? So now what happens? Float is usually double the size of an integer. So the float will take 8 bytes, and the representation is also different because it includes the decimal bit also. So when I say something like a float, because it includes the floating point values also, so let me just try to extend this to 64. Oh, too much. 64, right? It becomes 64 because it's a 64-bit or 8 bytes. So the computer representation, which says it's a IEEE format, so it will not store 1 in this particular format. It will have its own format and reserve some bits for the decimal points also. Hence, when you convert float, because see, float is already occupying 64 bits, now it is like keeping 64 boxes into 32 boxes, right? So you can see the arrangement cannot be made. Storing 32 bits of an integer into float is possible. You can directly place this 32 boxes in the 32 boxes here. But placing 64 boxes of float is not possible into integer. How will you manage 64 boxes into 32 boxes? So what happens? Somehow it tries to adjust, and in the meantime, everything gets garbled. So sometimes you may get a right answer, sometimes you may get a wrong answer also, right? As simple as an example, for example, let's say I'm storing a floating 1. So I will have all 0 again, continuing till here. Although this is a wrong representation, but just for your visualization, right? If I'm storing a floating 1, I will have the 64th bit as 1 and the rest is 0, because in mathematics I can write 1 as 0, 0, 0, 0, 0, 0, 1, right? This one is same as 0, 0, 1 and 0, 0, 0, right? So let's say I am keeping 1 in a floating value which takes 64 bits or 8 bytes. So the last value will be 1. So what is the simplest case of having 64 boxes into 32 boxes? You take the first 32 box and place it into the integer box. So now see, even though your value was 1, and different compiler treat this as differently. Some may take the bottom 32 and keep it in this 32, so that may give you a correct answer. Some may take the first 32 and keep it in this 32. So this is the representation why if you have something of floating 2.5 and you return it as int, the answer may or may not be right. It may give 2 also, it may give 0 also, it may give a random value also. I hope at least something is clear, right? So we will have a separate lecture on this number system, how the numbers are stored, integer, octal, decimal, hexadecimal, how the memory management is done. We will see that in future lectures. So for today, I am just covering the swapping thing. So we will take the swap variable. Okay, I think for today I should quit, because this swap thing I can explain tomorrow along, because tomorrow I will just begin a very small introduction to pointers. So class, you may have a drive in the CS102 Dropbox. You may have a folder called as reading. And that reading folder has a book called Let Us See by Yashwant Kanatkar. So just open that page and just write page number 195, right? Just write page number 195. Okay. So in page number 195, you see the font and the page size is too small, right? So for tomorrow's lecture, I would advise you, if you can read 15 pages from here, right? From 195 till, I think, yeah, from 195 to 203, right? From 195. So 195 begins from this point, call by value and call by reference, right? And we go up till back to function calls, right? Even if you can read this statement, it will be good, but just plainly read this. So tomorrow we will be explaining the pointers part, and this is explained very nicely in this book also, and I will also take an example to help you go through it, right? So today we can stop the lecture here. Fine. If you have any issues or doubt, you can tell me, or else we close the lecture and I will post the recording on YouTube. Yes. You can. Acha. So you can first send the code if it is relating to the code. I mean, if it is taking more time, and if it is not relating to today's lecture, let me ask somebody else who has doubts in today's lecture, so that by the time they all can leave, and then we can discuss. So class, let us see from page number, actually in PDF readers, there is some strange thing. When you write 195, actually the page number is 178. Fine. So just keep this in mind. The heading is call by value and call by reference. Just go through this for 10 or 12 pages and you will get an idea for tomorrow's lecture. That will actually help you a lot in understanding when you do it when VS Code and try to see the program output. So that's it for today's lecture. If the others do not have doubt, can actually leave the WebEx session. Others who want to ask questions can stay back. Balance one. Okay, let me just go to the code function. Yeah, what doubt? Correct. Actually, so whenever you are passing an array, it is always called by reference implicitly, even if you are not writing it ampersand, or even if you are writing it a variable name, right? Implicitly, the compiler has made it easy for the user. So even if I am writing balance here, internally, basically this is being passed to the function. That is the address of the 0th element of the array, right? But just for user convenience, it's just like when you drive a car, you need not know how the acceleration or the braking mechanism and the mechanics behind it work. You just know, okay, press this for faster speed, press this for brake. So just so that a user does not have to remember so many things, the compiler sometimes makes a job easy for a programmer. The question is really good. For example, when I'm passing phi to it, the size is basically passed by value, not by reference. But whenever you are passing an array, arrays are always passed by reference. The first address, basically the address of element 0 or index 0, is passed to the function. Is it clear, or tomorrow we can actually see it again by using directly the pointer? So you can actually, print here the address of balance. So you can do a printf %u ampersand balance. Check that address. Go in this particular function and try to get the address of this particular variable ampersand array of 0. You will see it's the same only. Fine. Yeah. Yes. 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 So that is a tricky question in C. So in C, basically you do not get such a feature. So there is something that you have to do it manually. So how do you do it manually? So let's say you want to design a program that calculates average, wherein you are asking user to enter the number of inputs. So what you can do, you can keep a very huge array, right? Balance 3000, something like this, right? And you can say user that your values, the maximum input value should be less than equal to 3000. Fine. So because see, everything has a limit, right? Even if you go on a weighing machine, it will have a fixed weight of 150 kg. Beyond that, if a person is beyond 150 kg, they cannot do anything, right? So here we are saying that our program can calculate the average balance up to 3000 values, right? So now you know that, assume it's a bank balance. So the bank balance cannot be negative, right? It has to be a non-zero, it has to be zero or more than zero. Fine. So what we will say user, we will keep a magical value. Magical value means anything which you know that will never be possible, right? So let's say you assume that you have to calculate the average age of a class, right? Let us take the example of an age. Now you definitely know that age cannot be negative under no circumstances. So your first line will be enter the number of ages you want to insert. So the user may say, okay, I want to enter 150 ages, right? But your array was of 3000. So either you can take 150 value and assume n to be 150, or you can say the user when you are completed ending all the ages, enter -1, right? Because you know that the age can never be -1. So let me show you an Excel example. So let's say I keep it age 1 and age 2, right? So let us say the user is entering some random age. And now the user is bored of entering the ages. So you have told ki, okay, when you finish entering ages, enter the last age as -1, right? So now you know wherever there is -1, that age is the last value. So you will write a for loop again. You will read the first value, second value, third value. You will keep on reading the values up till you encounter a -1. At -1, you know that, okay, now the age is done. Now the ages are finished, right? So this is like a manual check. It is not a very good approach, right? It is always not possible also, because see, for ages we know that -1 will never come, right? But let's say you want to compute the average of numbers. So for average of numbers, there can be a negative input also, right? It may be possible that -1 may actually be an input also. So for that cases, you need to, as I said, keep a magical value. In that case, you can keep a very large or a very small value, right? I hope this Excel makes it clear to you, right? In Python, there is a function known as length. So you can say, ki, okay, how many elements were there in the array, right? Because the negative point of C is you do not even have a bounds error. So let's say you define an array of 10. So basically you can actually input 30 values also using for loop. The compiler will not throw an error. It will keep on storing, right? So okay, so we are done. I think today 1 o'clock already has struck. So the length of the array is like, for example, assume from 40 years or 50 years previously, when computers were started coming into the picture. So that time we had memory storages like 1 KB, 10 KB or 5 KB, right? So when you say ki, okay, array of ages is 10, if one integer is taking 4 bytes, 10 integers will take 40 bytes in the memory, right? So when the compiler is executing, when the compiler is compiling your code, it actually checks whether 40 bytes of space is available in the memory or not available, right? So it's just like, when you see games, so the computer game says na minimum requirements 1 GB graphic card, 8 GB RAM and all these things. So that means ki, okay, whenever you are executing me, you need to have this much space so that I can execute correctly. So when you specify the array size, the compiler during the compilation actually checks whether that much amount of memory is available. If it is available, it will allot that memory. If memory is not available, it won't allot and it will not let you compile the program. But because nowadays we have 16 GB RAMs and everything, we never bother. We say, okay, no need to worry. So that is the reason we specify a size to tell the memory how much memory the program actually requires, to tell the operating system actually that my program requires this much amount of memory. If you have, kindly allot me. If you don't have, it will pop an error, insufficient memory. So this is like a security bug in C, right? So Java does not allow you, Python does not allow you. So it's like the program is breaking the trust of the operating system. So let's say I give you the cupboard. Now, if I give you my key of my cupboard and say, okay, go in shelf number 2 and pick up 2 books and return. Now, since you have the key, I will trust you that you will take only 2 books, but nothing stops you from taking other books and keeping in your own bag. So there is a thing called buffer overflow attack. That is a security architecture and security principle. So that attack is possible because of C compilers this feature that it does not check beyond the boundary. All right. So it should not have allowed, but the compiler, I do not know whether they have updated the compiler right now, but it still allows for taking excess values. So that is the thing. So should we close the session, guys?